In this next example, we are told that the profit P of a bakery is a function of the number of cakes C sold each month. And the first thing that I want to think about here is, what is the independent and dependent variables? We have two variables. We have P and we have C, our profit and number of cakes. And I want to know which one depends on the other one. I am also told that this is a function of. The function of here part tells us that I am inputting what comes after that, my number of cakes, into the function. So my independent variable here is going to be my number of cakes sold. I am inputting the number of cakes into the function, and then my output, what I get back, is the dependent variable, and that is our profit. And as we think through this, that should make sense that the profit that this bakery makes, it's going to depend on how many cakes they sell. If they sell more cakes, they're going to make more profit. If they don't sell many cakes, they're not going to have much profit at all. So now, if the name of this function here is called pro, maybe this is what they're creating in their Excel spreadsheet and they're calling this function pro, we can write these variables in the function notation by saying that their profit that they make, P, is equal to the name of this function here, pro, of C, the number of cakes that they sold. So I'm inputting the number of cakes into this function that's called pro, and what that gives me back is the amount of profit that they have. Next, we're going to do some practice here with evaluating functions. So I have three different examples where we have, the first one, we have g of x equal to negative 3x plus 1. And what I want to do is evaluate g of 10. So that means I am replacing the x in my function with 10. So this is going to give us negative 3 times 10 plus 1. So that is negative 30 plus 1, which is negative 29. The next one, we have f of x equal to x squared plus 7. So now to evaluate f of 3, we need to replace x in our function with 3. So we have 3 squared plus 7. So that gives us 9 plus 7, which is 16. And then our last function, we have h of x, and this is equal to 12 over x. So now h of negative 18, well, that's going to be 12 over negative 18, which then that can simplify to negative 2 over 3. And then our last example here with evaluating a function is we are asked or told that the height in feet of a ball thrown vertically upward t seconds after it's released is given by this equation s of t equal to negative 16 times t squared plus 64t plus 4. And what we want to do is find the height of the ball 3 seconds after it is released. So in this equation, t is representing seconds, so that means we need to replace t with 3, and we are going to be evaluating what s of 3 is. So s of 3, this is going to be negative 16 times 3 squared plus 64 times 3 plus 4. And now this equation, we can put this into our calculator directly like this if you have a scientific calculator. And you should then get 52 feet. And lastly, for this video, we're going to go over the graph of a function. And the graph of a function, what it is it's essentially the display of all of the ordered pairs that belong to that function. So if I have a graph, a line or a curve on my graph, and I pick any point on that graph, the ordered pair, the x and y values for that, I can then put that back into my equation and it will be true. For this example, we want to sketch the graph of g of x equal to negative 3x plus 1. And with functions, if we don't know what the graph is going to look like, we don't have any techniques or any special knowledge about what that graph should look like, one thing that we can do is create a table for different values of x and y. But in this case, our y is going to be the g of x. So I'm going to put in some different values of x into this function so that we can get what our g of x output is going to be. So maybe let's start off with negative 2. If we replace our x in our function with negative 2, we have negative 3 times negative 2 plus 1, which gives us 7 because the negatives cancel. And then maybe if we have negative 1, negative 3 times negative 1 plus 1, that gives us 4. And I'm also going to create a third column in this table here to give us our ordered pairs, the x comma g of x, or the x comma y, if you want to think of it like that, where we're going to have negative 2, 7. We also have the ordered pair negative 1, 4. And then let's continue on to get a few more ordered pairs for our graph. If I put in 0 for x, negative 3 times 0 plus 1, that just gives us 1. So we have 0 comma 1. And then if we put in 1 for x, negative 3 times 1 plus 1, well, that then gives us negative 2. To give us 1 comma negative 2. And then let's do one more to put in 2 for x. Negative 3 times 2 plus 1. And that then gives us negative 5. So we have 2, negative 5 for our last ordered pair. So now I want to take these ordered pairs and plot them on our graph. Our independent variable, the input, is always on the horizontal axis, so I'm going to label that as x. And then our output variable, that's always on the vertical axis. So I'm going to label that as g of x. And now for this, if I want each square essentially on my graph to represent 1, usually then you don't need to label it, but if you want it to represent anything else, a different distance, you would want to make sure that you have labels on your graph to indicate that. But this one, I'm just going to let each dash represent a distance of 1 so that I don't have to add a whole bunch of labels onto this. So now I want to take these ordered pairs and plot them on the graph. So my first ordered pair is -2, 7. So that means I'm going to start at my origin, the intersection, that's 0, 0, and I need to go -2 to the left and then up 7 from that. So that's right at the top edge of my graph is where my first ordered pair is going to be for the -2, 7. The next ordered pair is -1, 4. So I have to go left 1 from my origin and then up 4 for my second point. Next one, we have 0, 1. So that means we're going to be on the vertical axis, and then we just need to go up 1. Next one, we have 1, -2. So we're going to go to the right 1 and then down 2 from our origin. And then lastly, we have 2, -5. So we're going to go to the right 2 and then down 5. So now we have all 5 points plotted on here, and we're going to connect those together. And this function that we had was a linear function, so all 5 of these points are creating a straight line, but we'll talk more about linear functions in 5.2 for the next set of videos.